Find the trigonometric Fourier series of the triangular wave shown here. Now it starts from minus 2 pi, then minus pi, 0, pi and 2 pi. So here this point is nothing but it's minus pi by 2. This point is nothing but pi by 2. And it goes on. So here first we have to find the time period. This is a periodic continuous time signal. Now here the t can be from minus 2 pi to 0. It can be from 0 to 2 pi. It can be minus pi to pi. So we will consider t is equal to minus pi to pi. So from here it could be till here, or from here it could be till here, from here it could be till here. We will consider from minus pi to pi. So this is the time period. T is equal to find the time period, it's upper limit minus lower limit. Upper limit minus lower limit. Our upper limit is pi minus lower limit is minus pi. So your t is equal to 2 pi. First thing we have found. Second is omega naught, which is equal to 2 pi by t. By formula, when we substitute the value of t, it becomes 2 pi by 2 pi, which is equal to 1. Therefore, omega naught is equal to 1. We have found out t, we have found out omega naught. Having found t is equal to 2 pi, omega naught is equal to 1, our x of t is equal to, that is the amplitude, minus 2 into t plus pi by pi, and it's 2t by pi, and it is 2 by pi minus t by pi. So now we have found 3 amplitudes for 3 different time period. That is from minus pi to minus pi by 2. From minus pi to minus pi by 2. This is your amplitude. For minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. This is your amplitude. And from pi by 2 to pi. Pi by 2 to pi. This is your amplitude. So first the wave starts at minus pi by 2 and ends at pi. These are the intermediate different amplitude that has been obtained. Now we will see how to find each amplitude. With the help of straight line equation 2-point form, we can find the first straight line equation for minus pi to minus pi by 2. So this is the first thing we are going to find. Let's redraw it. It is minus pi by 2. Here the point will be x1 comma y1. Here it will be x2 comma y2. Now your x1 is minus pi and y is 0. x2 is minus pi by 2 and y is minus 1. Having these two, let's write the straight line equation. The formula is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1. This is an equation for straight line. Here x stands for t. So t minus x1 by x2 minus x1 equal to y stands for x of t. Your x-axis is t and y-axis is amplitude x of t. X of t minus y1 by y2 minus y1. Substitute the value of x1 and y1. You will get t minus of minus pi by 2 minus pi x of t minus 0 minus 1 minus 0. So it will be t plus pi by minus pi by 2 plus pi equal to x of t by 1. When you solve this, you will get it as x of t is equal to minus 2 t plus pi by pi. This is your first amplitude. The second is for the it starts from minus pi by 2 to pi by 2. Okay, so now we have to find the straight line equation for minus pi by 2 to pi by 2. So we have to have this as x1 comma y1, that is minus pi by 2 comma minus 1. Here it is x2 comma y2, that is pi by 2 comma 1. Let's find the straight line equation for this. My x comma x minus 1 x2 by x1 is equal to y minus y1 by y2 minus y1. As already said, the x is nothing but your t comma x1. Please substitute from here minus pi by 2. Again x2 minus x1. Pi by 2 minus of minus pi by 2 is equal to y, as already said, it's x of t minus of minus 1 minus, that is from y1 y2 y1 y2. We have substituted all the value. Now please simplify the above equation to get the value for x of t for the interval minus pi by 2 to pi by 2. And simplifying the equation, finally you will get x of t is equal to 2t by pi, and this amplitude is for the time period pi minus pi by 2 to pi by 2. So we have found out the second amplitude. We have completed 1 and 2. Now we'll go for the third part. I'm just redrawing that particular section. x1 y1 will be pi by 2 comma 1 and x2 comma y2 will be pi comma 0. Now this is for the interval pi by 2 to pi. We have already found for minus pi to minus pi by 2, and then we found for minus pi by 2 to pi by 2. Now we are finding for pi by 2 to pi. So having this, find the straight line, find the equation using straight line equation. So it's t minus pi by 2 by pi minus pi by 2. That is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1. I have directly substituted in the straight line equation, and now I am going to simplify it to get x of t value. Pi by 2 x of t minus 1. Further simplifying, it becomes minus t pi by 2 plus pi by 2 by pi by 2 equal to x of t. Furthermore, it becomes 2 into minus t plus pi by x of t. And when you further simplify, the last will be 2 into pi minus t by pi. This is for the interval pi by 2 t to pi. So finally, we have found x of t for 3 different time. Having t is equal to 2 pi, omega naught is equal to 1 and x of t is equal to minus 2 t plus pi by pi for minus pi to minus pi by 2. Then it was 2t by pi for minus pi by 2 to pi by 2, and finally it was pi by 2 into by pi for pi by 2 to pi. Having this, we are going to solve for the problem having x of t is equal to a naught summation n is equal to 1 for a n cos n omega naught t plus bn sin n omega naught t. Okay, here a naught is the DC component. To find a naught, you have to use the formula t naught plus t x of t dt a n is equal to 2 by t naught plus t x of t cos n omega naught t dt, and then bn is equal to 2 by t summation t naught plus 2 x of t sin n omega naught t dt. So you have to find a naught, you have to find an, bn, and finally substitute all the three in x of t. To find x of t is equal to a naught plus summation n is equal to minus infinity into infinity a n cos nt plus bn sin nt. We'll first find a naught. A naught is equal to 1 by t. Now the limit is from minus pi to pi x of t dt. Now the value of t, we know it is 2 pi. So 1 by 2 pi, and we have split the overall time period into 3. That is from minus pi to minus pi by 2. Okay, in which the amplitude is minus 2 t plus pi by pi dt plus minus pi by 2 by 2 2t plus pi dt plus pi by 2 pi 2 pi by t by pi dt. We have included all the three amplitudes. Further solving, we are removing these two outside. So 2 by 2 pi, the minus comes out. It's minus pi by 2 minus pi t by pi dt minus pi by 2 minus pi dt plus pi by 2 minus pi by 2 t by pi dt plus pi by 2 dt minus pi by 2 t by pi dt. Further simplifying, 1 by pi minus t square by 2 pi. We have integrating the above thing. Pi by 2 pi t. So it's pi by 2 minus pi plus this becomes t square by 2 pi and the limit is pi by 2 minus pi by 2. And then again it is t for the limit pi by 2. It's t square by 2 pi and the limit is pi by 2. Now we are going to apply the limit. As we apply the limit, we get minus pi square by 2 pi plus pi square by 2 pi plus pi by 2 minus pi plus pi square by 8 pi minus pi square by 8 pi plus pi minus pi by 2 minus pi square by 2 pi plus pi square by 2 pi. And now see you have minus pi square by 2 pi plus pi square by 2 pi. So you can cancel these two. There is one plus pi minus pi. Here minus pi by 2 plus pi by 2. So you can, if you see, you will get to cancel all the values and finally a naught will be equal to 0. So we have found a naught. A naught is equal to 0. Having found a naught, we will find an. So an is equal to 2 by t integral of t naught plus t x of t cos n omega naught t. So here we substitute 2 pi for t. We will get 2 by 2 pi minus pi. We are going to apply the limits. Minus pi to pi x of t cos nt dt. 2 gets cancelled. Now splitting the limits. It is 1 by pi. First limit is from minus pi to pi by 2. Amplitude is minus 2 t plus pi by pi cos nt dt. Then it's pi by 2 minus pi by 2 2t by pi cos nt dt plus pi by 2 to pi 2 pi minus t by pi cos nt dt. So here we are going to remove 2 by pi outside. From each term 2 by pi gets removed and we are going to multiply in the front with 1 by pi. So this becomes 2 by pi square into, for minus pi to minus pi by 2, it is minus of t plus pi cos nt dt plus pi by 2 and this is minus pi by 2. For this is t cos nt dt since we have removed 2 by pi outside. Then it is pi by 2 to pi for pi minus t cos nt dt. Now we are going to use integral by parts since we have two variables here. So when we have to use integral parts, this is your u value, this is dv and here u dt dv. Here u and dv. So it is integral u into dv is equal to uv minus v du. Integral u dv is equal to uv minus integral v du. So having that in mind, we are going to simplify this. This becomes minus 2 by pi square. It's minus t plus pi into sine nt by n. Applying the limits, pi minus pi by 2 minus pi plus uv into v integral v du. For that it is minus pi to minus pi by 2 sine nt by n dt. And then comes your second term. This was for the first term. Then comes for your second term. It is t sine nt by n integral pi by 2 minus pi by 2 minus, this is uv integral of v du. So again minus pi by 2 sine nt by n. So we have completed for the first term and second term. The third term is left. We will continue writing it down. It is pi minus t sine nt by n. Limit is pi by 2 to pi plus integral of pi by 2 to pi sine nt by n dt. So when you do integral by parts, you have found u dv. By applying the formula integral u dv is equal to uv minus integral v du, we have found the last. Further simplifying, we get 2 by pi square pi by 2 sine n pi by 2 by n plus 0 minus cos nt by n square. This is for the limit minus pi by 2 minus pi. Then again you have pi by 2 sine n pi by 2 minus pi by 2 sine nt by n plus, it's a big term so I am writing it below, by n square. Now this is for the limit minus pi by 2 to pi by 2. Then 0 pi by 2 sine n pi by 2 minus cos nt by n square for the limit pi by 2 pi. So now we have to again solve this. We are solving for an. Please don't forget that. After solving this, you will get 2 by pi square pi by 2n sine n pi by 2 minus cos n pi by 2 plus cos n pi n square plus cos n pi by 2 minus cos n pi by 2 by n square minus pi by 2n sine n pi by 2 minus cos n pi plus cos n pi by n square. If you add this and then this one and this one will get cancelled. Similarly, these three terms will also get cancelled. So finally, an will be left out with 0. So your a naught is 0 and an is again 0. Having found for a naught, that is 0, and an, that is again 0, we are going to find for bn, that is 2 by t integral t naught plus t T naught is the basic formula to find Bn, sin n omega naught t dt. Now here t is equal to 2 pi. So 2 by 2 pi integral minus pi to pi x of t sin n omega naught t dt. Then comes again solving. We know omega naught is 1. So this becomes 1 by pi minus pi to pi x of t sin n t dt. Applying the value of x of t for 3 different intervals. So 1 by pi is common here. Minus pi, and this is minus pi by 2, minus 2 into t plus pi by pi sin n t dt. Again, it is pi by 2 minus pi by 2, 2t by pi sin n t dt. Again, it's pi by 2, 2 into pi minus t by pi sin n t dt. Then it becomes solving it. We are removing my 2 and pi. So here it becomes 2 by pi square is common for all the 3 integrals. Okay, 2 by pi is common. So we multiplied with 1 by pi to get 2 by pi square. And then it becomes pi minus pi 2 minus pi by 2 minus t plus pi sin n t dt minus pi by 2, 2 pi by 2 t sin n t dt. Again, it's pi by t for pi by 2 to pi sin n t dt. Now, in all the 3 integrals, we see that there are 2 variables. So, again, we have to go by integral part. Integral by part. So, here this is u and this is dv, u, dv, u, dv. Now, we have to solve and find uv minus integral v du. In order to solve that, you will get 2 by pi square. It's t plus pi cos nt by n minus pi by 2 pi minus integral uv minus integral v du. For that, it is minus pi by 2 cos n dt by n, and then it is t cos nt by t. This is for the second part. Minus plus integral minus pi by 2 to pi by 2 cos nt by n dt. This is for the second part. Now comes the third. Minus n pi minus t cos nt by n pi, and here it is pi by 2 and minus integral of pi by 2. This is cos nt by n dt. We have done the integral by parts, considering this is u and dv, u dv, u dv. So then it becomes uv minus integral v du. This is uv minus integral v du, uv minus integral v du, uv minus integral v du. On further simplification, we get Bn is equal to 2 by pi square pi by 2 cos n pi by 2 by n minus 0. That is after applying the limits. You get sine nt by n square for limit minus pi by 2 to minus pi. Pi by 2 cos n pi by 2 by n plus pi by 2 cos n pi by 2 plus sine nt by n square plus pi by 2, and this is minus pi by 2. Minus 0, that is after applying the limits, n pi by 2, and finally it is sine nt by 2 for pi by 2 to pi. On further solving this, we will get 2 by pi square, 2 by pi square sine n pi by 2 minus sine n pi the whole divided by n square plus sine n pi by 2 plus sine n pi by 2 minus sine n pi by minus sine n pi by 2 the whole n square. So if you further simplify this and solve, you will get 2 by pi square and then 4 sine n pi by 2 by n square. The remaining will get cancelled. So finally your Bn value is 8 by pi square n square sine n pi by n square. So we have got a value for Bn. It is 8 pi square n square sine n pi by 2. Rewriting the value for A0, that is 0, An, that is 0, Bn, that is 8 by pi square n square sine n pi by 2. Your x of t, substituting all the 3 in x of t, we will get summation minus infinity to infinity, since this is 0 and again this is 0, 8 by n square pi square sine n pi by 2 and sine n t. This is your final equation.